So in this video, we're going to take a look at some standard general functions and then try and use some of their properties to help us answer some challenging math questions. So let's just start by running through the functions. Much of this you should know already. So the first type of function we're going to look at is a linear function, which means y equals mx plus c. So anything in that format where m and c are just numbers. So y equals 3x plus 2, y equals a half x minus 5. They're all linear functions. And remember, the steepness of the function is the m. So in that first example, look, it's 3. And in that second example, it's a half. Okay, that's how we look at the steepness. And the y-intercept, the c, is that number on the end. So in my first example, look, that crosses at 2. And in the second example, it crosses at minus 5. Okay, so those are linear functions. You should be comfortable and familiar with those already. Right, the second sort of function is a quadratic function. So that means anything that contains an x squared as its leading power of x. So anything really in the form y equals ax squared plus bx plus c, where a, b, and c are just numbers. And look, you can see some different examples given here. Now, if you can write them as ax squared plus bx plus c, then we can see some relationships between the values of a, b, and c and that graph. So, for example, where it crosses the y-axis is the number on the end, the c, right? Okay, so for example, you can see with this one, this example here is y equals x squared. Well, there is no number on the end, so it crosses at 0. This has the 8 there, look, okay, as its number on its own, so it crosses at 8. This final example here, look, has a 2 on its own, so it crosses at 2. So this number c helps us to find that. Another interesting feature of these graphs that you should be aware of is the number in front of the x squared, the coefficient of x squared. Because if this is negative, then we have this sad face shape. And if it's positive, we have a happy face shape, right? So let's take a look again at the 3 examples and make sure we understand this. So y equals x squared is a bit like y equals 1x squared. Well, that is a positive number, so we have a smiley face. In this second example, we have like a minus 1x squared, as the minus 1 being the coefficient of x squared, and that's negative, so you can see it's a sad face. And again, on that final example, we can see that we have like a 1x squared. One's positive, so a smiley face there, look, okay? So these things are really important. We keep an eye on that shape, right? Okay. Now, let's just carry on and have a look at some more unfamiliar types of function. So a cubic function. So this one is a little more complex than a quadratic. It has a power of x cubed, right? That's why it's called a cubic function. So it may have x squared and other values of x as well. All of these examples you can see in front of you are cubic functions. Now, some of the same principles apply from the quadratics as to the cubics, right? That number on its own, I'm circling now, look, okay, tells you where it crosses the axes, okay, the y-axis that is. So let's take a quick look and see if we can just find that. Look, well, in that first example, there is no number on its own. It's like a plus 0, so we cross at 0. Same for c, if we take a look at this one, look, there's no number on its own, so it crosses at 0. That middle one, though, look, does have a number on its own, 2, and that's why it crosses that y-axis at 2. So that any number that you see on its own without a value of x next to it is going to be where it crosses the y-axis, just like linear functions, just like quadratic functions. Okay, now the shape of the graph is also to do with the leading coefficient, this time though of x cubed. Now, if the value in front of the x cubed, like in all of these examples, is positive, then our graph goes from the bottom left to top right, so maybe something like that. If we have it negative, it's going to go in the other direction. It's going to go from top left to bottom right. That's a negative cubic. So look out for that as well. Okay. Right, in fact, there is an example. Look, there's a few examples here. Take a look at E goes from top left to bottom right because we have that negative symbol look in front of the x cubed. Same for f, top left to bottom right. So we can figure out something to do with that function if we know that leading coefficient of x cubed. Now, finally, we are going to take a quick look at reciprocal functions in this video. A reciprocal function is a fractional function with an x on the denominator. So can you see there's some examples there? Look, okay. Now, they all look the same. They're disjointed. They have two separate parts to them, and they have what's known as an asymptote, which means a sort of imaginary line that you never cross. So I'm illustrating, look, a couple of asymptotes on that first example. There's one at x equals 0 and y equals 0. So these are reciprocal functions. And there is a relationship. If we have a negative reciprocal, rather than being in the bottom left and top right, look for a positive value. When we have a negative, like in that third example, it's the other way around. It's top left and bottom right. So we can sort of work out some of the shape of the diagram from the algebraic functions, right? All of these are symmetrical. They all have lines of symmetry along y equals x and y equals minus x. Okay, so now we've done that, let's see if we can just classify some of these, right? Okay, so have a think about each of these, and you've got to decide, is it linear, quadratic, cubic, or reciprocal? So I'll write an L, a Q, a C, or an R, depending on the choice. So have a think about A. What do you think it is? Well, this is a reciprocal function. B is a quadratic function because its leading coefficient is an x squared. C is a linear function. It's going to give us a straight line. D is a cubic function. E is a quadratic function. And F is a reciprocal function. So hopefully you can classify these yourselves. Let's move on and see if we can try a more challenging question. Right, so let's now do the same thing with graphs, right? We've got to decide if it's linear, quadratic, cubic, or reciprocal. So A, well, it's curved. It goes from bottom left to top right. It is, of course, a cubic function. B has those asymptote lines and it's disjoint. That is a reciprocal function. C is a straight line. It's got to be linear. D, well, this is a cubic as well. It's curly. It's not a quadratic. It goes from bottom left to top right. E is a quadratic function. Okay, because it's got that either sad face or smiley face shape to it. And F, look, it's disjoint. It's got that symmetry. It's got to be a reciprocal function. So that is the answer to that question. Now let's go a little further, right? Okay, for a bit of extra challenge. Here we've got 4 different quadratics. We've got to label up and choose which of those algebraic functions match the equation. So let's start off with A. So first of all, it appears that we're crossing that y-axis. We're at +1. So we're looking for a function with a +1 on it. So already it's got to be either A or it's got to be C. Okay, now the next thing is it a happy face or a sad face? Well, it's a sad face, which means the coefficient of x squared has to be negative. Well, that clearly means that it's got to be C. So A matches with C. Let's put a line through that. We've eliminated that one, and let's move on. Okay, let's move on to graph B. Now, this one is a smiley face, which means we're looking for a positive x squared coefficient. And actually, all of them that are left all have that positive smiley shape. This one, though, crosses at 0 on that y-axis. So we're looking for the one that has no number on the end, right? Okay, because that means it crosses at 0. So, of course, It's got to be this one, hasn't it? It's got to be D. That doesn't have any number on the end. That's on its own. So we can say that B matches with D. Okay, so can you figure out now then what goes with C and D? Well, C matches with A because it crosses at 1 and A has a positive 1. D is going to match with B because, of course, look, it crosses there, look, at -1, and B has a -1. So we are done. Right, let's go on. Final question now. Okay, let's try and make this a bit more complex. So we've got 4 different graphs, but we've got 6 different algebraic equations. Can we work out which one is which? This is going to be pretty tricky. Let's go straight away and think about this. Now, before we even get started, we can perhaps narrow this down by going through each of the graphs and each of the pieces of algebra and writing down if they're linear, quadratic, cubic, or reciprocal. So I'm going to write them up for you. Hopefully you can see the same as me. That first one is linear, and so is that second one. The third one there, that's quadratic. This is a quadratic. Now, these next 2 are a little complicated, but it doesn't look quite right, but we could just divide everything by 2. This is equivalent to y equals 1 plus a half x. I'm just dividing both sides by 2. And this other one here, well, this doesn't look quite right either, but maybe I could divide both sides by x. So y equals 1 over x. So that fifth one there, look, that was linear. And that last one, well, that was a reciprocal function. Okay, now let's go through the graphs in exactly the same way and make sure we can understand which is which. So part 1 is a quadratic, part 2 is a linear, part 3 is quadratic, and part 4 is a reciprocal. Okay, well, clearly we've only got one reciprocal function in the algebra and in the graphical interpretation. So these 2 have to go together, don't they? That is going to be 1 over x. Right, what about our quadratics? Well, this in the top right corner of the algebra, look, okay, y equals 1 minus x squared. That has a negative number in front of the x squared. Well, that means a sad face, doesn't it? So that one has to go over here with the sad face. That's going to leave this one to go as the happy face, okay? So that is going to go there. So now all we've got to do is we've got to consider that part 2. Now, this is a straight line. It has a positive gradient and it crosses the y-axis at a number greater than 1. So which one of those linear equations has a positive gradient and has a number greater than 0, I should say, sorry, as its y-intercept? Well, it has to be this one. This has that positive gradient, and it has a number larger than 0 as its y-intercept, so it's going to go here. Now, that got a bit messy, but hopefully you followed it, okay? That's how we match those up. Right, hopefully you've learned something about the different types of graph and can use that to answer some math questions.